Hey guys, it's Ms. Johnson, and I'm here to bring you our notes for Unit 2, Notes 2, which is on finding values from percentiles. So we are going to talk about how to find a percentile of a given data set today. So Unit 2 is all about kind of positioning of data. Yesterday we talked about the standard deviation, which was what's the variance from the mean of the data set, the typical variance or the typical variation of the mean from in the whole data set. So today we're going to talk about what percentile, what value in the table marks a certain percentile. So if I say this person is in the 90th percentile of their class, what does that value translate to? What value gives you the 90th percentile of that data? So we're going to be looking at some tables today, and we have kind of this little formula, if you will. It's not really a formula, but this is just showing you what the math is of how we create it. So whatever data value that we're seeking, this is what we're looking for. Okay, the percent that we want to write that percent out as a decimal, and we're going to multiply that by n, and that gives us the position in the table. Okay, this gives us the position in the table that marks that value. Okay, so that's what we're going to be doing. So then we find the data value that corresponds to the number that you calculated, that corresponds to that position. Okay, so we're going to look at a couple of big tables today, and we're going to talk about how we find certain percentiles. All right, so here's our first data table. This is a data set. We've got a big long data set here. It's got a lot of values in it. And what we want to be finding, there's a few examples down here. We have P7, P36, P71, and P60. What this is the 7th percentile, okay, or the 36th percentile. That's what these mean here. 7th percentile. So if I say to you, what's the 7th, what value marks the 7th percentile of this data table? That's what we have to find. Okay, now, the first thing that's really helpful when you're looking at a big long table like this is we're going to kind of give ourselves some positionings over here out on the side. It's really hard to go because you're going to be having to count through here. If I say to you, find the 96th value, you don't need to start at number 1 and count all the way up to number 96. That's kind of a silly waste of your time. So what's going to be really helpful is we're going to number off our table just off to the right-hand side so that I know at least each row, what the end of each row, what position that is in the table. So if I count off, this is the first data value. That's the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. That's the 10th data value in my table. Every row has the same number of values. So this is the 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th data value. So 26 is data value number 20. If I keep going all the way down, this would be 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And you can kind of see a pattern here. There's 10 columns across, which means that there's 10 values in each row. So each row, the next row counts up by 10. So 131 is the 50th data value. So this is 60, this is 70, this is 80, this is 90, this is 100, this is 110, 120, and 130. And again, this is just all about positioning. Okay, this is what data value number you are in the table. The other thing that's really good about doing this is you now see that 343 is the 130th data value in your table, which that also gives you your n, which is what you need. You need to know how many data values you have. Okay, so there's 130 values in this table. All right, so if I want the 7th percentile, if I want P7, that means I need to take the 7th percent as a decimal, which is 0.07, and I'm going to multiply that by the 130, which is my n. So this is my percent times my n. And again, you need to make that percent a decimal. If you don't remember making percents decimals, wherever your decimal point is, doesn't matter where your decimal point is. This trips people up all the time. Wherever your decimal point is, you move it back 2 places. Always move it 2 places. In this case, that gave me an open hole. I fill in that open hole with a 0. So I've got 0.07 times 130. Type that into your calculator. 0.07 times 130 gives me 9.1. So I am looking for that position in my table. So what I get here is 9.1. Now, this is marking a specific data value, okay? It's 9.1 data value. We don't know what 9.1 is. That doesn't make any sense. All of our positions in the table are whole numbers. So what I need to do is I need to round that to the nearest whole. Round to the nearest whole. And my nearest whole number here is the 9th data value. So this tells me that I am looking for the 9th data value. Okay, so if I go up into my table and I look for the 9th data value, part of what's nice about numbering these columns off to the right-hand side here is that I know that 11 is the 10th. This was my 10th data value. So I just need to go back 1, and my 9th data value is equal to 8. Okay, my 9th data value is 8. So that means P7 is equal to 8. So the 7th percentile of this data set is 8. So again, you have a percentile that you're turning into a position in the table. Once you find that position in the table, that's the value that's marking your percentile. Okay, so this whole positioning piece is like the middle point of your process. So let's do it again. Let's look at P36. So for P36, that means I'm taking 0.36 times my n, which is 130. Okay, it's similar to saying, like, what would 70% on a test score be? If I wanted 70% of a test score, I would take 0.7 times the total number of points, and that tells me what 70% on that certain test is equal to. So in this case, I'm looking for the 36th percentile, so 0.36 times 130, which is 46.8. Now, that's not a position in the table. That's a partial number. So I need to round to the nearest whole. So that means I want the 47th, if I put my 4 in, the 47th value. Okay, so that's the position in the table that I'm looking for. I'm looking for the 47th value. So if I go back up to my table, again, the side markers just help you quickly locate where that is. Instead of having to start it up here and count all the way up to 47, I know that this value right here is number 50, which means that that's 49, that's 48, and that's 47. So the 47th value is 128. That's what that said, right? Yep, 128. So that means that P36 equals 128. Okay, let's take a look at P70 or 71. So P71, I'm going to turn that into a decimal. I turn it into a decimal by moving it back 2 places. So that's 0.71 times my n, which is 130. That's going to give me 0.71. I'm just typing that into my calculator. Times 130, I get 92.3. This is equal to 92.3. But you can't have a 92.3 position in the table, so I'm going to round it to the nearest whole. That means it's the 92nd position. Okay, then go look for that 92nd position. So here's number 90. I know that 191 is number 90. So I'm going to go down to the next row. That means that this is 91, this is 92. So my 92nd position in the table is 218. So the way we write that out is P71 is equal to 218. And again, what that's telling me is the value 218 marks the 71st percentile. You can kind of think of this in terms of class rank. I know you guys don't use class rank very much anymore, but if you were calculating your class rank, you'd be a certain position out of your whole entire class, then what percentage would that be? Okay, so that's kind of what we're getting at there. So the 71st percentile in this particular data set is the value 218. All right, let's do it one more time for this table. So again, P60, people get tripped up when there's a 0 at the end. You have to move it 2 places. That's 0.60. So 0.60 times 130. In my calculator, 0.6 times 130 is 78. This one I get a whole number, so that's good. So I know I want the 78th position in the table. So that whatever the 78th position in the table is my 60th percentile. Here's number 80. So that means that this is 79, this is 78. So down here, that gave me, oh, I just lost it in my head, 167. So that means that P60 is equal to 167. So again, the 60th percentile in the data set is 167. Let's do it with one more table and just make sure that we kind of have our acts together here. So we're going to find the following percentiles one more time. So I'm looking for the 4th percentile, I'm looking for the 43rd, the 82nd, and the 68th. All right, so again, it's really helpful if you number off your table so that you can find those positions quickly. This is a large data set. You don't need to spend your time. It's a waste of your time to sit and count all the way through all of them. If you number them all off at the beginning, it just helps you locate those positions a lot faster. So let's see how many columns we have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. That means that this is position number 12. So that means this is position number 24, and I'm going to count by 12s all the way down. So that's 36, that's 48, that's 60, 72, 84, so I'll write smaller, 96, 108, 120, 132, 144, that's 156, 168, 180, and 192. Oops, I forgot my 100 there. And I'm just going to spot check myself. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rows. So if I take 16 rows times 12 data values across, I get 192. So good. I know I counted right there. Okay, so my N is equal to 192, which is a good thing to know. All right, so now let's talk percentiles. So for P4, P4 means that I go back 2 places. I need 0.04 times my N, which is 192. 0.04 times 192 is 7.68. If I use my rules of rounding tell me that I'm looking at the 8th position. So if I'm looking at the 8th position in the data table, my 12th position was here. That's 12, that's 11, that's 10, that's 9, that's 8. Okay, so I'm looking at 5. So that means that P4 is equal to 5. So the 4th percentile of the data table is the value 5. That's what we're answering here. Okay, so let's take a look at the next one, P43. Go back 2 places. That's 0.43 times the 192. 0.43 times 192 gives me 82.56. And again, I'm going to use my rules of rounding because 82.56, that's not a position in the table. I have to have a whole number. So that means I'm looking at the 83rd position. So if I come back up here, here's the 84th. The 83rd is the next one in, that's 99. So my P43 is equal to 99. The 82nd percentile, P82 means the 82nd percentile. So I have 0.82 times 192 0.82 times 192 gives me 157.44. Use my rules of rounding there. I'm going to stay at the 157 because 4 is below 5. So I want the 157th value. And that, I keep stringing my U and my E together, sorry. And that 157th value, let's come back up here. Here's 156, right? 192, 180, 160. Here's 156. So then 157 is the next one down, which is 198. So if I mark that with my notation here, I have P82 is equal to 198. And again, these positions are equating to the values. So this 8th position equated to number 5. This 83rd position equated to the data value 99. Okay, let's try one more for this table. So I've got 0.68 for a percentile times the 192. 0.68 times 192. And my calculator gives me 130.56. I'm going to round up there. So that's going to be the 131st position. And let's see what that is in my table. So 131. Here's 132. Here's 131. So I'm looking at 153. That's equal to 153. So again, if I write that out using my notation, the 68th percentile is equal to 153. All right, so hopefully that gives you a little bit of a picture of what we're doing here, finding percentiles using the N and the percentile as a decimal to get your position in the table, then finding that position in the table, which marks the data value you want. So thanks for listening, and I will catch you next time.